Hello, my name is Bob Evans and today I am going to talk about the basics of retaining wall design. There are many types of retaining walls and they all fall into three major categories: gravity, cantilever and reinforced soil designs. You can see examples of a cantilever king post and many L-shaped designs. The gravity design can be improved using reinforced soil when the wall height increases beyond the economical gravity wall design. Our structural engineer designed retaining walls to Eurocode 7. The Eurocode gives design guidelines and standards to ensure the wall passes design tests with factors of safety. Retaining walls can fail in a number of ways. The material being retained creates a force that causes toppling of the wall. Bearing capacity. The weight of the wall and earth is supported by the ground beneath. The wall can settle and fail. Sliding. The retaining earth creates a horizontal force that can cause the retaining wall to slide. This is resisted by the friction between the wall and earth beneath and the embedment of the wall. Stability. The earth around the wall requires adequate strength to avoid an overall slip failure. Shear. The blocks and masonry can shear at the base or on courses. Bending. The king post wall can bend if the steel section is not adequate for the load case. This video shows how a retaining wall slips and overturns. The leg of the retaining wall is facing outwards and glass marbles are placed behind it. You can see how the wall slides. A rubber mat is now put down. The rubber mat represents friction. The retaining wall is placed on the rubber mat and is again loaded with the marbles. The mode of failure this time is overturning because the rubber mat is resisting the sliding. The weight of the marbles at failure is 8 centimeters. When the wall is turned around, so the leg faces inwards and the retaining wall is loaded with marbles, you can see the marbles now sit on the top of the retaining wall leg and the height of the marbles is 11 centimeters before failure. You can now see why it is vital that your retaining wall project is engineered in accordance with Eurocode 7. Structural engineers need soil information before they can design a retaining wall. Different soils have different properties. There are 3 quick ways to get soil information for small projects: borehole, trial pit and a desktop study. You can hire a bore tool or a JCB to dig into the ground to obtain the information. You take samples from a number of depths and record the depths and soil sample. The engineer can also access borehole data from the British Geographical Survey. This is what a borehole log looks like from a professional site investigation report. On large projects, the architect or engineer will commission a full site investigation survey. This includes looking at floodplains, soil chemical analysis and a number of boreholes carried out by a geologist technician. The table shows simple field tests to determine the ground condition. The table shows a number of soil types and a simple field test to find out the condition in terms of hardness. From the descriptions, the engineer can determine a value for the bearing capacity of the ground the retaining wall will sit on. Download the slides and study the table, then carry out your own field test from the excavation material from your trial pits or boreholes. Video your results when trying to squeeze the material. Key benefits of structural design. The retaining wall will not fail subject to being built to the design. You will have the correct material specifications. You will have a copy of the calculations for third parties. You will have a section through drawing of the wall. You will be protected by the engineer's professional indemnity insurance. This is an example of a king post design for a small housing project. This is an example of a gabion wall requirement for a housing development. This is an example of an inclined concrete block for a car park on a commercial project. A cast in L shape and concrete crib block design. a hollow block, step-up and GeoWeb reinforced soil retaining wall design. Every project is different with different soil types and site constraints. We highly recommend your retaining wall project begins with a structural design. The next step, ask a question, tell us about your project and complete the form on the page and we will get in touch. Thanks for listening. Bye for now.